Everyone. I'm Sunanta from SNS College of Technology, Department of Mathematics. Here in this lecture video series, we are going to see quantitative statistical measures, and that we are having measures of central tendency and measures of dispersion. So in this lecture video series, we are going to see measures of central tendencies, which means arithmetic mean, median, and mode. So in this video, we are going to see arithmetic mean. So let us see uh, what are all the things that is going to be covered in this video, which are uh, understanding central tendency, next arithmetic mean, next how to apply arithmetic mean to real data, next is the properties of arithmetic mean. So here, the central tendency refers to statistical measures that identifies a single value as representative of an entire distribution of data. It aims to provide an accurate description of the entire data set with one value. Here, the mean means the average of all the values of the data sets. Then the median means the mid value, and the mode means the highest frequency or the most number of repeated frequencies. The next is what is the need to identify or what is the need to use central tendencies. So here, to simplify large data set into a single representative value, compare different groups or population, next to make informed decision based on data, next communicative finding effectively. Next here, this is the definition of arithmetic mean. It is the sum of all the observations by the number of observations. It is most widely used central tendency, and it is also known as average. And this is used in two ways, depending on the data. When the data is a grouped one, then we use the formula x bar is equal to summation fi xi divided by n. And if the data is ungrouped, then we use the formula summation xi divided by n. Next here, let us see one problem for ungrouped data. Here the daily sales of a retail store over 7 days are 12, 15, 18, 14, 20, 16 and 19. Here we are going to find the arithmetic mean of sales. So here there are totally 7 days data. So which are 12, 15, 18, 14, 20, 16 and 19. So the n value is 7 here. Then to find the summation xi, we have to add this 12, 15, 18, 14, 20, 16 and 19, which is 114. Next, we have to use the formula. So here we are going to use the ungrouped formula x bar is equal to summation xi divided by n. So we have 114 divided by 7, which results in 16.29. So that is the arithmetic mean of the given problem. So now let us see a ungrouped data. So here the scores of the classes are given in the range, so which is grouped into intervals from 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. And the corresponding frequencies are given as 5, 8, 12, 10, 5. Next, the mid values are find for the range. So 10 and 20, the mid value is 15. Next, for the data 20 to 30, it is 25. For 30 to 40, it is 35. 40 to 50, it is 45. And 50 to 60, it is 55. This is the table value. From this, we have calculated the midpoints. Next, we are going to calculate what is fx. To find fx, we have to multiply the frequency f with the midpoint value x. So 5 into 15, 8 into 20, 12 into 35, 10 into 45, 5 into 55. Next, we have to find the sum of the frequencies, which is summation f. 5 plus 8 plus 12 plus 10 plus 5. Next, we have to apply the formula summation fx divided by summation f. So adding the fx and divided by summation f, we get the final answer for this problem. So the next is properties of arithmetic mean. So sum of deviations is 0. So the sum of deviations of all the observations from their mean is always zero. The second one is affected by extreme values. The mean is sensitive to outliers and extreme values, which can significantly shift its value away from the typical data point. Next is algebraic treatment. The mean can be used in further algebraic calculations, and it is the basis of many advanced statistical measures like variance. Next, the advantages and limitations of arithmetic mean. So it is easy to calculate and understand. Use this as this is used in most of the data values, suitable for further analysis in variance, standard deviation, and in some other measures also. Next, unique value. Only one mean will exist for all the data sets. Next is algebraically defined. This can be manipulated mathematically. Next is limitations of arithmetic mean are affected by outliers. That is, extreme values can distort the mean significantly. Next is may not represent actual data. That is, the mean value might not exist in the data set. In some cases, the mean value won't be in the data set. Next is cannot be used for qualitative data. So, will be only a numerical data. So, misleading for skewed distributions. Not ideal when data is heavily skewed. Next is requires all data, so this cannot be calculated without incomplete information. Next is a real life case study in which a pharmaceutical company manufactures tablet with a target weight of 500 mg. So the quality control measures the weight of 50 tablets from each population batch to ensure consistency. So here the 50 tablets is the n value. Next the mean is 498 mg. So next is for next step will be the analysis. So compare batch mean to the target mean. The next will be the decision. So the batch falls within acceptable range, then it will be approved. Next will be the actions. So document results and continue monitoring subsequently. So this is the real life case study which involves mean. Thank you.